What's up, you freaking geniuses? So in this video, I'm going to teach you how to determine if two lines are perpendicular, all right? And there's basically three different ways or three different theorems that we can use to figure that out, okay? So the first case is going to be right here, okay? So if you have, so you can see these two angles right here, they are supplementary angles, right? So if I told you that these two angles, let's just label them 1 and 2, okay? If I told you angle 1 is the same, or in other words, congruent to angle 2, then you can assume that these two lines right here, G and H, are perpendicular, okay? Because the only way that angle 1 and angle 2 can have the exact same angle is if they're both 90 degrees, right? Because angle 1 and angle 2 right here, they're supplementary angles, so they have to add up to 180 degrees, right? And the only way we can do that is if we do 90 plus 90. Okay, so again, if these two lines intersect and these two angles are congruent, then you can assume that these two lines are perpendicular, okay? And that's known as the linear pair perpendicular theorem, in case you want to know the name, okay? Now, the second case here is when we have a transversal that runs through two parallel lines, okay? And you can see that these two are parallel because they have these little red markers on them, right? Or arrows on them. Okay, so since these two lines are parallel, if I told you that this transversal and this line on top were perpendicular, then that means this transversal and this other line on the bottom would also be perpendicular, okay? So we can only make this assumption that these two are perpendicular if these two lines right here, so in this case H and K, are parallel, okay? That's super, super important. You have to know first that these two lines right here are parallel. And if you do, then again, you can make this assumption, right? And this is known as the perpendicular transversal theorem, again, in case you want to know the name. Okay, now this last case is kind of the opposite of this last case right here, okay? So if you have two lines, so lines M and N right here that are perpendicular to this exact same line right here, this transversal, line P, then you can assume that these two lines, M and N, are parallel, okay? And again, you can make that assumption because they are both hitting this transversal, line P, at the exact same angle. And this one is known as the lines perpendicular to a transversal theorem, right? So now that we've got this little intro out of the way, now let's jump into just a few examples. All right, so here's the first problem. So it says determine which lines, if any, are perpendicular. Okay, so it's giving us this right off the bat. Okay, so it's saying that line V right here and this line right here, Y, are perpendicular, right? They both form a right angle. Okay, so we can say that V and Y are perpendicular lines, okay? Are there any other perpendicular lines? Okay, well, you might be tempted to say, yeah, maybe this one is also perpendicular. But the thing is, we can't make that assumption, okay? Because if these two lines right here, X and Y, if it told us that these were parallel, then we could totally say that these lines right here, V and X, are perpendicular, okay? Because then in this case, we would have two parallel lines, right? X and Y, and they would both be perpendicular to this transversal V, right? So if this one's perpendicular, we can assume this one's perpendicular. But again, that's not the case in this example, right? It doesn't tell us that X and Y are parallel, okay? So we can't make that assumption, all right? And for the exact same reasoning, we can't say that this angle right here or this angle right here are perpendicular, okay? Because we don't know if any of these lines right here are parallel, okay? So again, you can only make those assumptions if you know you have parallel lines. And in this case, since it doesn't tell us or it doesn't give us that, then we can't assume any of these other angles are perpendicular, all right? So in this problem, the only lines that are perpendicular are V and Y. All right, here's the next one. So this one says determine which lines, if any, are parallel, okay? So we're switching it up a bit, right? Okay, so it's giving us right off the bat that these two angles right here are perpendicular, okay? So since these two angles are perpendicular, can we assume that these two lines, B and C, are parallel? Yes, we can, all right? Hell yeah, all right? The reason for that is because both of these form the exact same angle with this transverse line, right? This line A right here. Okay, so since they both form the exact same angle with the exact same line right here, again, we can assume that these two lines B and C are parallel, right? So we can say B is parallel to C. All right, here's the next one. So this one again says determine which lines, if any, are parallel. Okay, so in this case, what lines are parallel? Okay, so what we can see here is that these two lines M and N, right? M and N, they are both perpendicular to the exact same line Q, right? So that means M and N must both be parallel, okay? Because they form the exact same angle with the exact same line, okay? So M and N are parallel, okay? What other lines can we say are parallel? Well, there's actually nothing else we can assume, okay? Because we still have this right angle right here, okay? But we don't know if L is parallel to M and N, okay? So that's why we can't relate this angle to these two lines over here or to these angles right here. Okay, similarly, we don't know if P and Q are parallel, okay? So that's why we can't just assume and relate this angle, this right angle right here, to like this one right here, okay? Again, you can only make those assumptions if you know the two lines you're talking about are parallel. Okay, so in this case, the only lines that are parallel are M and N. Okay, here's the next one. So this one says determine which lines, if any, are parallel. Okay, so again, in this one, we're not going to be able to assume any of the lines are parallel. Okay, so first of all, it's giving us these two right angles right here, okay? But they are not related in any way, okay? These this perpendicular angle is made by these two lines, A and D, and this perpendicular angle is made by these two lines right here, right, B and C, okay? So we don't have the same angle perpendicular to the same line, okay? So we can't assume that any of these lines are parallel, all right? So in this case, we're gonna say which lines are parallel? None of them, none. All right, last one. So this one says find the value of x that makes A perpendicular to B. Okay, so here's A, here's B. We want them to be perpendicular to each other. Okay, so if they're perpendicular right here, that means this angle right here has to be equal to 90 degrees. All right, so that's how we're going to solve for x right here. We're going to set this little expression right here equal to 90 degrees. All right, so we're going to have 5 times x plus 7 in parentheses plus 15 is equal to 90, okay? So solving for x right here, first thing we can do is distribute, right? So we'll have 5x plus 35 plus 15 is equal to 90, right? Now, here we're gonna have 5x and 35 plus 15, that's equal to 50, right? So plus 50 is equal to 90, right? So then here, we'll get rid of the 50, so subtract from both sides, cancel out right there. So you get 5x is equal to 90 minus 50, which is 40. Right? So then here, lastly, we'll get rid of the 5 by dividing by 5 on both sides. These cancel out. So we get x is equal to 40 divided by 5, which is equal to 8. Right? So then here we get x is equal to 8. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below. Also, there's a couple playlists attached that I think you'll find helpful, so definitely check those out, and I'll see you there.